All right, good afternoon, everyone. I have the privilege of being the last talk before the free beer downstairs. We're going to talk about Yuneec and change management, like what is it that we're actually trying to manage, how we're going to change really actionable data for your companies. And I have a technical question. Do I click the slides? Thanks for making it easy. And actually, I think that's sort of a key part to the talk, right? What's the easy button? There's a lot of things to know about software. There's a lot of things to know about drones, but how do you actually make this, easy and consumable? So again, my name is Phil Mann. I'm general manager of Yuneec. The parent company is Advanced Technology Labs. We are a global company. I'm going to explain a little bit about our company, and then we're going to talk about robots that collect data. That's the drone and the camera. Then we're going to talk about, how do we analyze the data? What are we actually using this data for? And we'll try to wrap that up. There's a demonstration of our particular drone at 5:30. A colleague of mine is also in the audience, Professor O'Leary, who is president of Universal Aerial Ventures. He's both a consultant and a customer, but he's in the business of providing the service of delivering that actionable data through aerial solutions. So, Advanced Technology Labs, Yuneec. We're a robotics and technology company. We are global. Yuneec is the flagship of our company. Some of you will know our company, some will not. But you can see we're worldwide here in California, Germany, Switzerland, China, and Hong Kong. If you've been paying attention to Yuneec, the company has a lot of attributes on the drone side. 2015 is when Intel made a $100 million investment to go into consumer drones. In 2020, we exited consumer drones, but along that way, it came up with an award-winning hexacopter design. That's what you see here up front. We'll show a little bit more about that. Great stability in the wind, good size, good performance, good pricing. And the company is exclusively focused now on enterprise drones and turnkey solutions. So for the energy sector, what are we trying to do? We need a robot that's going to collect data. So here's a robot. This happens to be the Yuneec one, but all downstairs, there's many versions of these, and you've been hearing about all day. What do you need? You need something that's stable. It needs to work all the time. It needs to be reliable. A windy day can't defeat you. A rainy day cannot defeat you if you're going to be doing this 24 hours a 7, scaling nationwide. The data needs to be secure. Lots of discussions on the cybersecurity front there. Best way to make it secure is don't broadcast the data, leave the data on the drone, only the user can access it. No one camera does it all. So it needs to be versatile, plug and play on that. Of course you need precision. An RTK solution can do that. There are other ways to do that. Versatile payloads. What if I want LTE? We heard from Skyward this morning about their LTE network. What if I need a drop kit? All kinds of things. It should be autonomous. Today, one of the things that slow us down from scale is one pilot, one drone. How do I make more autonomous missions? And many of you would like it to be PX4 based. Open source, I can add my own attributes to that particular drone or UAV. So let's take a look at what this robot looks like. So here we have something that is carryable. You can also see it up, on stage. I can have two pilots for safety, one looking at the payload, one flying the particular drone. This particular case, the landing gear goes up such that the camera can see 333 degrees. So I can fly the drone in one direction, I can point the camera in another. Again, that's versatility. So here you can see that the drone is flying around in a port environment, very heavy in metal. I can do my autonomous mission. So here I'm looking at a map. I'm deciding where I want to do. This is a construction site that we're looking at here. It needs to be easy to fly, easy to use, portable, as I've said before. So here I'm showing you that autonomous mission, because now I want to fly a mission. Maybe I want to fly it one day, every day, once a week, once a year. I want to see what has changed time and time again. So that mission planning needs to be simple. Here's some tools that are showing you what has changed over time. This is using, again, photogrammetry. The drone The camera, in this particular case, a well-known data side. Here I'm using a thermal camera for inspecting a building. I'm actually inspecting the quality of this particular building. This is actually Chasco Construction here in Texas. So again, that versatility in cameras. Lots of different types of things that one can inspect. We have a customer in Arizona who uses the drone for orthomosaics, so they can actually make a commercial view of the building as it is constructed over time. But this could be a power plant, this could be a gas plant, this can be a pipeline that we're doing with these things. So here we're inspecting a particular roof. This is a 640 by 540 FLIR sensor. This was actually something a project that Universal Aerial Ventures had. The straight lines there are actually the power lines on the roof of the building. I can detect water leaks. But this is a real service providing actionable data. Here in the final segment, towers. I want to inspect a particular tower. Stability in the wind is key. Again, reliability, everything that we've talked about, those attributes, for a particular drone. We know many tower companies would like to be able to see the labels on the back. I'm not sure I recommend flying as close as this pilot was flying to these antennas. They are expensive. But that's the robot. It's three-dimensional, it's carrying a sensor, it can be a methane detector, it can be a camera, it can be a thermal, whatever you need that for whatever it is I'm trying to measure. If I'm trying to measure any type of change, you want that versatility. So robot, data collection. We've talked quite a bit about autonomous missions. There's no such thing as one size fits all. I might want to survey a structure. I may need a particular corridor that I'm looking down if I'm doing a highway inspection or a long pipeline. Wall or facade if I'm doing that tower type of inspections. Again, these are just attributes. Obviously, we're showing here you the Yuneec drone, but these are the attributes you're going to want in any type of UAV. So now that we've collected the data, what do we need to do with it? So I have this data. We've partnered with a company called Skyline Soft. This is using their PhotoMesh and Terra Explorer. So here, a drone just like this was pulled out within about 10 minutes. It's flying a particular mission, and in a few hours later, we're looking at specific measurements within centimeters of what's going on. What you saw earlier was trying to fix what a fence line should look like. This is for public safety. I want to see the sight lines. The green is what the person can see from that spot. The red was what I couldn't see. Here I'm going to look at slope, like where would water collect? And I'm just looking at a picture here the photogrammetry gives you, but then the drone is providing that actionable data. Do I need to do something different to my building? Here's a quarry. This was taken 1 week apart. And I do recommend if you've got questions about how something like this was done, Josh O'Leary here can answer all of this stuff. So you create a point cloud or an orthomosaic. And what you're going to see here is if it's blue, it's new, and if it's red, it's been removed. So you can measure very precisely how much earth was moved or how much was changed in this particular period of time. Again, I've got the robot, I took some data. What am I going to do with that data? So here we're looking at slope again. It's actually misleading to look at the water that was collected. It doesn't tell you anything. It just says water collected over some time. Where did it go? What direction? Here I can measure the volume of what has changed in terms of dirt, in this particular case, earth being moved. But this could be anything, right? I could be a methane detector, which has been a lot talked about here at the conference. This happens to be the OSU Medical School. So here's a drone flying. There's particular attributes being able to do this in shady spots where you can see these orange markers. This is where some construction is going on. This tells us that this proves to us that the digital twin is very precise. Now I want to do something. I want to know where to put the pipes underground. So with the software, this drone turnkey solution, I can manipulate my data. Where am I going to lay these pipes underground? And then finally, we were talking about that tower inspection. Well, then I want to make a digital twin of that. We heard quite a bit about that, earlier today. So here's my digital twin. Is the antennas where it's supposed to be? Has anybody stuck something on? This last one is for fun. This was done at AUVSI in Atlanta at an FAA event. This was literally this was get the drone, a 12-minute flight, under an hour of processing, and we're rendering this digital twin right here, right now. So I think if you were in the keynotes this morning, right, KVS Technologies and Sprite were talking about how they take their drone, they put a lot of automation in, but they deliver an actionable answer. Is there something that needs to be fixed on the power grid lines? That's what I think this summit is all about. It's not which drone is better, what camera is better, what software is better. It's what data can you have, and then what can you do with it? So we're a big proponent of just trying to present, a version of that. Now, this particular one is probably being used in a commercial for this microbrewery Steadicam, which makes mighty fine beer, I must say. So just summarizing, right? This is, 2D, 3D modeling. Again, I've picked a building here where the measurements are accurate within a few centimeters or 1¼ inch. The change management here on a quarry we've selected. This is what we're trying to do here. I thought I'd throw this open to questions. Things that you've seen in here that you would like to know more about. If you want to know how the service was actually enacted, we can answer that here as well. And at 5:30 downstairs with a cold beer in your hand, we're going to do a demonstration with our drone in that small cage area down there. And with that, thank you so much for your time and attention. You won't say. Questions? Editorials? This company company is called It's called Skyline Soft, and the product is PhotoMesh and Terra Explorer. And you can also get that through Yuneec as well. So no, it's not exclusive to the Yuneec platform. There is a version of it that goes along with the Yuneec, and they have their, but no, they're not. They're drone agnostic. I mean, we're friends. All right. Anything else from any of the audience watching from home? Yeah.
What's the status of the E430? Is it still around?
The E430?
Yeah.
Even I don't know. All right, ladies and gentlemen, thank you so much. I hope this was a wonderful day for you guys, and join us downstairs. Thank you.